So lactate concentration itself does not give any explanation on. To be fair, most of the swimming performances are happening. You will also get aerobic and anaerobic energy contribution, VLamax, VLamax, even substrate utilization. And so what this means, you now can measure the economy in the efforts you're actually interested in. You can actually put a number to it and quantify it, say, this is how much speed or energy the athlete is losing or winning. That the more time you spend at a high fraction of VO2max, the bigger the improvements of VO2max are. You can define the most individualized based on the unique physiology of an athlete training zones you can get. All that not reflected, not able to decipher that from a lactate incremental test. Let's discuss 3 things which you can integrate into the testing and coaching of your swimmers, which you likely don't do yet. Number 1, testing your athletes, testing the performance of your athletes. Likely you will do one of the 2 following testing protocols. Number 1 common protocol is we just do all-out tests. We just do some kind of race simulations over different distances to understand what is the maximum speed, what is the best time actually, the swimmer can achieve in a certain stroke over a certain distance. Normally, obviously testing the strokes and the distances we are interested in for training, but especially racing. And then we use those times to break down percentages of it to say, okay, this is X percent I want to use for my interval set. This is X percentage I want to use for this kind of training, and so on and so forth. The upside of that is it's very close to the real condition you're interested in, because at the end, what we want is we want to swim faster over a certain distance. And it's also pretty easy and practical to do. The downside is it doesn't tell you anything, not one single thing about the physiology, about what actually changed from a physiological point of view in a test or retest scenario. And for the very same reason, because it's not telling you anything about the physiology, it is not disclosing anything about what are, from a physiological point of view, areas for improvement and areas where your athlete already is pretty good. And let's make no mistake, physiology, aerobic capacity, buffering capacity, anaerobic power, all these things, which we're going to talk about a little bit here, are ultimately those metrics which you try to improve by training and swimming. And the downside is, if you use these very practical, very spot on, all-out race simulation type maximum efforts of your athlete to progress their performance, to monitor the progress of their performance, yes, we do understand how fast they swim, and do they swim faster or slower than 2 months ago or last month, but we don't understand why that is. What changed in the physiology? How did our training actually work? That's one way how testing is done in many, many cases. The other group of coaches, so to speak, painting a little bit black and white here, is doing lactate testing, incremental lactate test, 4 times 200 meters, 3 times 400 meters, whatever you do, right? So some kind of lactate testing where, similar as they do in other sports, you kind of incrementally increase the load in basically the swimming speed, test the lactate pre-post, get the lactate profile curve. Great. Then what most people do, break down these lactate concentrations and say, we want to swim at a lactate of 2 millimoles or 3 or 4 or 6 or 8 for whatever training intensity zone. Great. You can also do that. Maybe you even get a threshold value and break down percentage of threshold. Cool. Downside is you entirely miss out on the other part. Most of this test is done sub-maximum. So tracking best performances, no, not happening, right? You would have to do these all-out tests over certain distances in the specific strokes of the swimmer, backstroke, butterfly, whatsoever, additionally to that test, adding to the time. And then the other downside is what you're actually doing in this lactate incremental test, you're mimicking some kind of quasi-steady state conditions, right? 400 meters steady speed. And to be fair, most of the swimming performances are happening at a mixture of aerobic and anaerobic energy contribution. It's a mixture of higher VO2max, better swimming technique, better swimming economy, buffering capacity. Again, all that not reflected, not able to decipher that from a lactate incremental test. So yes, it gives you a little bit a snapshot into the physiology, as much as you are able to see, oh, the lactate is higher or lower. But this is where it ends. So lactate concentration itself does not give any explanation on, is the lactate concentration, for example, lower because the athlete combusted more lactate, meaning higher aerobic capacity, or produced less, meaning lower glycolytic capacity. So also not perfect. So what are you able to change? Here are the three things we are going to talk about. So here's number one. If you're doing these lactate tests, you can still do that. If you're doing these all-out tests, different strokes, different distances, maximum speed, you can also still do that. What you're actually able to do, you're able to combine those two. Doing a few submaximum effort with measuring lactate. For example, it can be even a warm-up, right? If your specific stroke of the swimmer is, let's say, butterfly, you can do freestyle in a warm-up, take lactate after 3, 4, easy, shorter distances, and then design the protocol that you want in terms of, hey, I want 50-meter butterfly, 100-meter butterfly all out, I want 100-meter backstroke, 200-meter back, whatever it is, okay? Design the protocol containing the distances and the strokes that you're interested in, and just measure lactate before and after. And then when you plug this into Insight, we are able to decipher, be able to disclose what was the actual lactate production and lactate combustion that created the concentrations that you measured. Now that might sound very nerdy and you might say, okay, why is it important to me? Why it is because the lactate production is directly linked to the maximum anaerobic capacity of the athlete, or VLamax to be more precise. And the lactate combustion is directly linked to the aerobic capacity, or VO2 max of the athlete. So by doing that, designing a protocol however you want it, some easier warm-up, freestyle efforts to get training zones for the freestyle endurance training, volume training, so to speak, combined with whatever all-out efforts, race simulation in the specific stroke of the athlete, you design whatever you want, you take lactate pre and post, and besides just getting only the lactate curve and the lactate concentration, you will also get aerobic and anaerobic energy contribution, VO2 max, VLamax, even substrate utilization, and how fast the athlete accumulates lactate and how quickly the athlete can combust and therefore recover from high lactate, for example, in between interval sets. So what I'm saying is you get this complete huge metabolic profile. So you have a much, much more complete picture of, if you, for example, do a test and retest, so testing and retest after a training block, you can now understand in very great detail, for example, why did the speed, why did the speed increase, why did the time over whatever, my 100 meter all out, 50 meter all out, 400 meter all out, whatever it is, why did it improve? Was it because the aerobic system got stronger? Was it because the glycolytic system got stronger? And so on and so forth. Number two, swimming economy. We don't need to argue about that, I think. We don't need to argue about that. The swimming economy, what I mean with that, the energy demand to swim a certain speed at a certain stroke, obviously, is crucial to performance. We have seen from elite triathletes to modern pentathletes to elite swimmers to recreational swimmers, amateur swimmers, we've seen tremendous differences in the energy demand to swim a certain speed in a certain stroke. Meaning, swimming economy, so energy output, energy demand to swim a certain speed, differs tremendously in between athletes. Often, this offers the single biggest room for improvement. So how do you measure that? The first thing that might come to mind is that, I need a snorkel, I need a 30K VO2 analyzer, I need to go into a flume, I will not have the real swimming technique, can do flip turns, or it's in a flume, and therefore, it's not realistic. That's gone. That's from the past. You can now test in the pool, on the pool deck, easily, just putting the VO2 analyzer on after the effort. And we do the math for you. We do the math in terms of, we do a fitting of the offset of the VO2. It's called backward extrapolation. It's scientifically well explored. And you can get the actual VO2 number pretty precisely during the effort. Great. Now you can say, okay, I can do that. That sounds good. But similar to our problem with the lactate testing, you can only get reliable numbers if you do that. You only can get a reliable analysis for the low speeds, for your training speeds. And to be fair, how much are you actually interested in swimming economy, in sub-maximum, let's say, freestyle effort of your 100-meter fly athlete? It's not so relevant, right? Is it? So why can you not do it after 50 meters fly or 100-meter fly or whatever your specific distance is? Well, very straightforward. Because in the majority of all swimming events, there's a very, very big amount of the energy of the performance contribution coming from anaerobic metabolism. And obviously, anaerobic metabolism, as the name tells you, is not measured, is not covered by doing VO2 measurements. So your VO2 measurement that you can do in the pool is not cutting it when it comes to the economy that you're interested in. And this is the economy at your all-out race simulation events, right? So what I'm saying is you should not be so interested in if you're a fly or breaststroker, has a good swimming economy at low speed freestyle. You are interested in, hey, what is the economy at race speed at the specific stroke? And VO2 does not measure that because a majority of the energy is coming from the anaerobic sources. Now, again, what you can do now, you can combine this VO2 measurement with a lactate measurement. Just pre-post this effort lactate, you plug it into Insight, and what it does, it analyzes the energy from the aerobic part and the energy from the anaerobic part. And by adding those two together, you now get the total energy demand or energy expenditure, even in short 100-meter race simulation-like efforts. So what this means, you now can measure the economy in the efforts you're actually interested in. Big improvement, very important point, because now you can really understand, hey, is there something to learn from that? Can this athlete gain performance improvements from improving technique? And you can actually put a number to it and quantify it, say, this is how much speed or energy the athlete is losing or winning, gaining over his peers over data that we have stored from the literature. You can compare it to that and say, okay, how good is the athlete from economy point of view, and therefore likely how much room is there for improvement? So that was number 2. And number 3 is setting training zones. That goes a little bit back to the testing. So one thing that you will likely want from performance testing in swimming is not only what we discussed, seeing the progress of an athlete from a test to retest scenario and understand better how the training actually worked and what it did trigger in terms of adaptation and what it didn't. Again, we discussed that, and you need to look at the physiology. The other thing that you likely want to get from such a testing is indications for speeds, for lap times, for your training. Either it's endurance training or it's interval training, high intense interval training, extensive interval, whatever it is. You want that. Okay, so we discussed that. How do you do that? Well, you do your old school conventional all out efforts over several distances, take a percentage. But then you don't really know what is actually going on physiologically during these efforts. Or, as we discussed, you maybe do a lactate test, and you do know now, this swimmer at whatever, after 400 meters and that whatever lap time has a lactate concentration of 3. Now, you cannot extrapolate that and understand, this would be the lactate concentration after 200 meters or 600 meters, or 800 meters or 50 meters at a different speed. So the application of that value for these values is very, very limited. Plus, on top of that, just because you know the lactate concentration, you don't know what else is going on. So, giving you one example. Scientific literature, I'm going to link it here in the article. Scientific literature tells us that it's pretty well researched and proven that the more time you spend at a high fraction of VO2 max, the bigger the improvements of VO2 max are. So therefore, for example, you would want to look at, what is the VO2 max utilization during the interval training I like to prescribe in my athlete, in the specific athlete based on the individual physiology. And these are your best times, your lactate concentration training zones model tells you that. So what I'm telling you here is now, when you do what we discussed previously in step number 1, when you do have this whole metabolic profile, you can actually now create training zones first based on the metrics you're interested in. So instead of defining a training zone as a percentage of best time or the lactate concentration from whatever distance that was used in the test, you can go in and say, hey, for each individual athlete, based on the individual physiology of this athlete at this moment, I want to know, give me the speed or the lap time that triggers 95% VO2 max after 200 meters in freestyle swimming. Boom, you get the speed for that. Give me the speed lap time for 20% anaerobic energy contribution over 400 meters freestyle. Get it. All these things. Give me the speed that triggers 10 millimoles of lactate after 100 meter breaststroke. Boom. Whatever it is, whatever your training is, you can define a zone. And not only a training zone, you can even define a distance and say, yeah, I want to do this over 200 meters, 100 meters, 400 meters, whatever it is. Okay. And Insight's training zone builder will tell you exactly the speed in that specific stroke over that distance. And then on top of that, you can ask the question, okay, what else is going on in the metabolism? So for example, you create your training zone based on lactate concentration because that's what you're used to. Fine. But maybe you want to know what is the percentage of VO2 max that I'm utilizing or what that the athlete is utilizing here. So what is the aerobic training stimulus? So for each training zone, you can ask 5 of those questions and say, I want to know 5 physiological parameters: percentage VO2 max, lactate concentration, percentage of anaerobic threshold, aerobic energy contribution, carbohydrate combustion, lactate clearance for the recovery rates, whatever physiological marker you're interested in. You can get this for every speed over every distance you prescribe in your training. I know it sounds crazy, but it's already in use with several swimming teams, national swimming teams and federations across the globe successfully. You can define the most individualized, based on the unique physiology of an athlete, training zones you can get for whatever your training regime is. It's not about the training philosophy. You have your training philosophy and you do have the intervals you want to do, and now you can understand what's actually going on during those intervals in each specific athlete based on the individual physiology, and therefore understand what will likely be the training result, what is the training stimulus, what is the training trigger. And that you can do for any training zone you want. So those were the 3 things. It doesn't take a lot in terms of you can either keep doing the testing protocols that you currently do, or if you're not happy with that, you can design whatever testing protocol you want. You can design testing protocols specifically for the swimmer of concern. You can do it for, if you have a fly sprint swimmer or a freestyle, more like long or mid-distance swimmer, whatever protocol you want, you can use. You will always get the same metabolic profile, all the metrics, VO2 max, VLamax I talked about, with the same accuracy. You can measure the economy and the efforts that do matter, and you can get the specific training zones with the specific physiology of the swimmer for whatever distance and speed you like. I will link all that, more explanations, the science behind it. I will link all that, how that works, in the article here, so you can take a deeper dive if you want. Thank you.